Good morning. This is Unit 2, Day 12 notes. We're going to go over the sum and difference formulas for cosine and sine. They actually derived it because of cosine, and they said that the distance between this point and this point, so this is the point 1 and point 2. If we rotate it, rotate cosine, this distance is going to be the same as this distance between this point and right here. And this distance right here, or this point right here, is at 1, 0. And this maybe is AB. And they actually use a distance formula to prove that if we rotate it, it'll be the same. I'm not going to go over the whole distance formula because it's super complicated the way they put these distance formulas together, and you don't really need to know this. You just need to remember that your x is your cosine, so x squared plus y squared equals 1 in the unit circle, the Pythagorean theorem. My x squared plus my y squared is always going to be equal to 1 on my unit circle. And you know that my x's are my cosines, so cosine squared. Let's use theta plus sine squared equals 1. We know this Pythagorean identity from the first 2 days. From this, we have derived the cosine formula. This is going to be the cosine difference formula. So cosine of, let's say, alpha minus beta is equal to cosine of alpha times cosine of beta. And then plus sine of alpha times sine of beta. So I always remember cosine is the opposite. If we're subtracting, then it's going to be plus in the middle. If we are adding, let's say this is cosine of alpha plus beta, then it's going to be same thing, cosine alpha, cosine beta. But this one is going to be minus sine alpha, sine beta. Okay, and this has to do with cosine and sine being odd and even functions. These will change, but these will not. All right, so this is why we're going to use this. Say we're asked to find cosine at 75 degrees and we're not given a calculator. All we know is 30, 60, 90, 45, 45, 90, and the axes. So we can also find cosine at 180, 270, and then any multiples of 360, which we can do 0 or 360 is fine. We can find any of these. We know cosine at any of these, but we don't know cosine at 75. What we can do is we say, oh, well, cosine of 75 can be cosine of maybe 45 plus 30. I know that whenever I'm ending in a 5, I'm going to use 45 plus one of the other ones because it's the only one that has a 5. Okay. Now 45 is going to be my alpha and 30 is going to be my beta. And I'm just going to plug it into my formula. So I'm going to plug it into the sum formula, which is cosine of alpha, which is 45, cosine beta, beta is 30, and then we're going to subtract sine alpha, alpha is 45, times sine beta, sine of 30. Now I need to know these two triangles. I'm going to draw them for you up here so we can plug them in, maybe down here. I know that this is a 45, 45, 90, and I'm going to circle this one. My opposite is 1, 1, square root of 2. And then I have to also know the 30, 60, 90 for 30 degrees. I'm going to plug in 30 only. I know opposite the 30 is the smallest, 2, square root of 3. And I'm going to circle the 30. Okay, so I'm going to label this side. This is my opposite, this is my hypotenuse, and this is my adjacent. I'm going to label this one. This is my opposite, this is my adjacent, and this is my hypotenuse. Hopefully this helps a little bit quicker. So cosine of 45 plus 30, or cosine of 75 degrees, is cosine at 45. Well, I know at 45 cosine is 1 over square root of 2, and we don't write it like that. We always rationalize the denominator, so it's the square root of 2 over 2 times cosine at 30. Cosine at 30 is adjacent over hypotenuse, so that is the square root of 3 over 2, minus sine at 45. At 45 degrees, sine is 1 over square root of 2, or the square root of 2 over 2. And then sine at 30, sine is opposite over hypotenuse, which is 1 over 2. We just multiply straight across when we're multiplying. So the square root of 2 times the square root of 3 is the square root of 6. 2 times 2 is 4, minus 2, square root of 2 times 1 is just the square root of 2, over 2 times 2 is 4. Now when we are subtracting, we have to have common denominators, which we do. So it's all over 4. The numerator we can add and subtract. The square root of 6 minus the square root of 2. These are not like terms, so it's just going to be the square root of 6 minus the square root of 2, and you're done. This is my final answer for cosine at 75 degrees. Now let's do cosine at pi over 12. We don't know pi over 12. We only know pi over 6 is 30, pi over 3, and pi over 4. But pi over 12, I know that 4 and 3 go into 12. So let's try splitting this up. What if this is cosine, right, cosine of 4 pi over 12 minus 3 pi over 12. Because 4 minus 3 is 1, and that's what I need. I need 1 pi over 12. Okay, now I can simplify this. I know that cosine of 4 pi over 12 is the same as cosine of pi over 3 minus cosine of 3 pi over 12. 3 pi over 12 is going to be pi over 4. And I'm going to write down the difference formula for cosine. Remember, if there's a minus, then in the middle of our equation, we're going to add. We're going to do the opposite. So it looks like pi over 3 is my alpha, and pi over 4 is my beta. So it's going to be cosine of alpha times cosine of beta. Instead of minus, it's going to be plus, because cosine is the opposite. And then it's going to be sine of alpha times sine of beta. Okay, I know my special right triangles, and actually they're right here. All I'm going to do is write in there 60 degrees, because in this case, 60 degrees is going to be my reference angle. Pi over 3 is 60 degrees. Alrighty, cosine at 60 degrees. Remember, cosine is adjacent over hypotenuse. My adjacent side is 1, and my hypotenuse is 2. Cosine at pi over 4, or 45 degrees, is 1 over square root of 2, and we always rationalize that as a square root of 2 over 2. Now it's plus. Sine at 60 degrees is opposite over hypotenuse, which is the square root of 3 over 2. Times sine at pi over 4 is going to be opposite over hypotenuse, which we rationalize it as the square root of 2 over 2. And you guys can multiply this and add it together and find out what this equals. These are the corollaries for the sum and difference formula. They just want you to know that at pi over 2 minus theta, it's going to be, of course, cosine of alpha times cosine of beta plus sine of alpha times sine of beta. But cosine at pi over 2 is 0. So this is 0 times cosine of theta plus sine at pi over 2 is 1 times sine of theta. If I multiply this by 0, this equals 0. So 1 times sine of theta is sine of theta. Also, for the sine formula, we know that sine is cosine shifted over pi over 2. So it's cosine at pi over 2 minus whatever this is, which is parentheses pi over 2 minus theta. And I know that this is cosine of pi over 2. I'm going to distribute this negative, okay? So pi over 2 minus pi over 2 plus theta. So these will cancel. Pi over 2 minus pi over 2 is 0. And then we'll just have cosine of theta. The way we figured out, or mathematicians figured out cosine or sine, is from cosine. We just shifted it over pi over 2. The signs did change. So this is what the cosine formula looks like. This is just saying that we can regroup it just like this. And this is equal to cosine of this whole thing can be our alpha. So it'll be pi over 2 minus alpha, and then cosine of beta, plus, since it's minus, I know I'm going to do plus, sine of alpha, which is pi over 2 minus alpha, times sine of beta. So sine of alpha plus beta, the actual formula is going to give us sine of alpha cosine beta plus cosine alpha sine beta. This is my sum formula for sine. So in the sum formula, cosine and sine alternate. Sine alpha, cosine beta, they alternate. Cosine alpha, sine beta. And then if this is plus, this one will stay plus. Let's do the difference formula for sine. It is, so sine of alpha minus beta is sine of alpha cosine beta minus cosine alpha sine beta. So same thing, but if it's minus, it'll be minus. We're going to use this if they ask us to find the exact value of something. We can't plug that into the calculator. Find the exact value, so they're all right here. Find the exact value of sine at pi over 12. I can help you guys set this one up. So pi over 12, we already did this. This is sine at pi over 3. I think it was pi over 3 minus pi over 4. Because pi over 12 is, we said 4 pi over 12 minus 3 pi over 12. Okay, and then the sine formula, we're going to do the difference formula. So this is going to be my alpha, this is my beta, and this is sine of alpha so sine at pi over 3, cosine of beta, cosine of pi over 4, and then minus cosine alpha, cosine at pi over 3, sine of beta, sine of pi over 4. So you guys can figure these out and subtract them. Now this one is the opposite. Do you guys see that this is my alpha? This is this formula right here with a plus in the middle. So this is my alpha, and this is my alpha, right? Now my alpha is going to be pi over 18. So I know this is a sine formula because it alternates sine and then cosine. So this is sine of pi over 18. And then since this is plus, I'm going to have a plus. Beta is going to be 5 pi over 18. So 5 pi over 18. You guys can add these and find out what it is sine of, and then you can actually find sine of that. Looks like 6 pi over 18. Simplify this. It'll be one of our nice numbers that we can figure out. This is going to be our last one for today. If you have another one, I want you guys to try these out. And if you have any questions, let me know.